system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
Crust and this is the lava which comes out. Let me form the mountain first. So this is the landform, right? So the lava comes out in this formation, right? As well as inside, wherever there are weakness and gaps, it goes along that. These are what? Sills, right? These are sills. If I make this will be dikes. Correct, no? These are dikes. Anyway, the gap in the top surface, you can see here, this is a gap like this, little conical in shape. This is called as crater. C-R-A-T-E-R, crater. This is extensive lava sheets. Whereas these are highly fluid Java, right? So this is a basic lava, how it comes across. Okay, here these are the hottest lava. How you can classify is, these are the hottest lava which are about 1000 degree centigrade, or you can say 1830 degree Fahrenheit. They are dark colored basically. They are dark colored, like basalt. Okay, like basalt, they are dark colored. They are rich in iron. They are rich in iron and magnesium, but they are poor in silica. Clear? As they are poured out, these are poured out of the volcano, they flow quietly, they flow very quietly and are not very explosive. They are not very explosive. They go very slowly. I mean, this will come out very slowly. It won't be coming at a very huge pressure and very huge speed. When it comes with a huge pressure and speed, what happens? There will be explosion in the top. So there is no such explosion. We don't find any explosion over here, but rather they are very slow. I'll put the point so that it will be not explosive, not very explosive. Clear? So they are not very explosive, and due to their high fluidity, they flow readily. They flow readily with a speed of, their speed is approximately 10 to 30 miles per hour. 1 mile is equal to 1.6. So accordingly you can calculate. So the speed is approximately 10 to 30 miles per hour, and the effect extensive areas. They affect a very extensive areas. Affect very extensive areas because they flow. Since the speed is 10 to 30, they flow quite a large area. Okay, spreading out as a thin sheets, as I have shown over here, right? Spreading out as a thin sheet. So the resultant volcano is gently sloping with a wide diameter and forms a flattened shield or a dome. You can see here this looks like a flattened dome or a what? A shield. So this is what? This is the basic lava. As I told, there are two types of lava. So that is the basic lava which we are discussing over here. Okay. So now we'll go to the second part. So basic lava, this is what I have mentioned here. So now I'll go to the second part, that is, but I should do it here so that I can show the difference. I'll do it here itself, so you can see the difference basically. This is earth crust, okay. Anyway, so what I'm doing is I will draw the diagram for acid lava. Just try to differentiate from the diagram. This is the earth crust, right? Earth crust, okay. Here, how it will be. This will be this. You can see the difference. So this comes out something like this. Right? So here the conical part is called as what? This is called as crater. Right? These are steeply sloping, these are steeply sloping areas, whereas this is sticky viscous lava. Which cannot flow far. Which cannot flow far. Right? So this is a basic difference we generally get in. So you can see the difference between the slopes, right? So the first one, which goes very slow and goes with a very small height, is called as basic lava, whereas the other one is acid lava. Now what are the important thing in here? In acid lava, I'll just write it in this side. So here this is important because these lavas are highly viscous. These are highly viscous with high melting point. With high melting point, right? Apart from this, they are light colored, of low density. They are light colored, of low density, and have a high percentage of silica. Whereas in the first case, what it was, there were iron and magnesium, whereas in this case we get high percentage of silica. They flow slowly. Here also they flow slowly, but travel far before solidifying. Before they solidify, they travel much larger. Quite obvious, because when they are going more top, when the vertical height is more, obviously what happened? The gravity will be more, correct or not? The gravity will be more compared to the first case. So the flowability and the distance covered will be more compared to the basic lava. So the rapid of lava in the vent obstruct the flow of the outpouring lava anyway, resulting in loud explosion. Here we can find explosions. And why? Because the rapid congealing of lava. Here the lava, here it will be rapid congealing. So of lava in the vent. This is the vent, right? Crater, below the crater. So there in the vent there will be a larger explosions, throwing out many volcanic bombs, and because of this will throw many volcanic bombs, which are also called as pyroclasts. Okay, volcanic bombs means those are also called as pyroclasts. And sometimes the lavas are so viscous that they form a spine or a plug at the crater, like that in Mount Pelée. There is a Mount Pelée, there is a mountain. So I'll discuss this after this. As of now, you just make a note. This is quite similar what happens in Mount Pelée. So Mount Pelée is nothing but this acid lava, right? Mount Pelée in Martinique. So some spines are very resistant, while most
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free AMC.